Hi everyone and welcome to SAMA, an interview series which invites experts each week to discuss their area of expertise. This week we're very lucky to have Gerald Pollack to discuss the fourth phase of water. Just when you think you know everything about water, there comes a curveball. Gerald received his Ph.D. in Biomedical Engineering from the University of Pennsylvania in 1968. His interests have ranged broadly from biological motion and cell biology to the interaction of biological surfaces with aqueous solutions like water. He received the Biomedical Engineering Society's Distinguished Lecturer Award in 2002, and in 2016 he was awarded the first Emoto Peace Prize. Well, we've got to talk about that one too. So thank you for accepting our invitation to our show. It's fantastic to have you with us.
Thank you. Thank you. Appreciate that. Happy to be with you. Well, would you like me to talk about the Emoto Peace Prize, or maybe that comes later?
Well, let's talk about this now, because I'd love to know how you got involved and a bit of your background so we understand the man in front of us now. So what is the Emoto Peace Prize?
Well, the Emoto Peace Prize was a huge surprise to me. I was the first recipient of the Emoto Peace Prize.
Yes.
And let me tell you, that was the last thing I expected.
Yes.
So I was invited by the Emoto people. You know, I was a fan of Masaru Emoto, and I really enjoyed looking at the images that he produced.
Yes.
And Emoto was controversial. He passed several years ago. His work is being carried on. The leader is his son, and his mother, Emoto's widow, is involved, plus several other people, and they've all become good friends of mine. And so they invited me to give a talk in Tokyo, and the talk was a 2-day talk. It was not a simple talk, and I presented a lot of stuff, and the reason they invited me is that our discovery of the fourth phase of water provides a scientific underpinning of what they've been complaining. It doesn't prove that what they've done is correct by any means, yes, but it does provide a scientific underpinning in an area where people say, this is impossible, it simply can't be. But I think it might be that it can. So they invited me. It was 2 days. The Japanese people were incredibly gracious and warm, and I've had a lot of experience with Japanese people. I've been to Japan perhaps 40 times. And most often in my experience, Japanese people tend to be subtle. You got to read between the lines if you really want to understand what they're trying to tell you. But this was different. These people were refreshingly open-minded and warm and hospitable. And my wife and I had a fantastic time over there. So after 2 days of almost continuous lecturing to 2 different groups of people who were interested in Emoto kinds of things, at the end, the guy, a fellow named Nemoto, who at the time was the president of the organization, he said, save me 15 minutes at the very end. So he saved 15 minutes, and he came on stage with some kind of statue or something, and also what looked like a diploma or a picture. It was wrapped, and I could imagine what that might be, because in the past, you know, very often you go give a talk and they prepare a plaque for you. Thank you so much for your wonderful lecture, or whatever, even before they've heard it. So I was expecting something like that.
Yeah.
To my surprise, when I'm standing up there with my wife on the podium, and I opened it, and it said, awarded to me the first Emoto Peace Prize. And I must tell you that, you know, having won various awards and prizes, this one was really, really meaningful. Why on earth would I be getting a Peace Prize?
Yes.
Well, I can't give you the answer to that, but it's really useful because if my wife and I are having a fight, I can just whip out that Peace Prize and tell her how reasonable I must be. Otherwise, I wouldn't have gotten that prize. So So it's very useful.
Let's hope
Anyway,
you have. Yeah, let's hope you haven't had to use that Peace Prize that often.
no. We get along just perfectly well, but it's a good story anyway.
It's a great story. Now,
Yeah.
back to water. How did you get interested in water? How did it all start? Because you've delved quite deeply with no pun intended into
Well,
this.
it started. There were a few factors. So I began my career and spent a good portion of my career studying muscles, trying to figure out how the proteins in muscle, actin and myosin, come together to produce force, energy, velocity, and such. And there was a theory that had been out there. The theory is still out there. In fact, it's hardly changed in 60 years. And it was put forth by a famous Nobel laureate whose name is Sir Andrew Huxley. He passed several years ago. He was a really distinguished guy. I mean, he had every accolade that you can imagine. He was not only won the Nobel Prize, but he had been president of the Royal Society, master of Trinity College, Cambridge, and also a distinguished lineage that goes back to Thomas Henry Huxley, and Aldous Huxley, the author, and so. But he was the only one who had won a Nobel Prize. So he was the kind of guy, when he walked into the room, there was a hush. It was like God has walked into this room. And unfortunately, in my view, none of the evidence fit his theory. So this was a problem because we had done many experiments and almost nothing agreed with the predictions of that theory. And we were pretty vocal about that, and I think I became a kind of nemesis for him. But we were on very good terms. He even sent Christmas cards, or his wife did, each year. So the problem, though, is that when you have God who's come forth with a theory, you believe it must be true. You can't really contradict God, can you? So, despite the fact that the evidence absolutely failed to fit the theory persisted, and in fact, it persists even to this day. And the theory developed to describe how muscles work has been extended to describe any kind of biological motion. And so I'm sorry to be so blatant, but I believe it's completely wrong. I mean, completely. It's not even close. So at the time, we were studying muscle contraction, and we began coming up with alternative ideas that seemed to fit the evidence better. But one of the things that struck me was that nobody talks about water inside muscle. Now, they talk about the proteins inside the muscle, but when you think about it, the fraction, the volume fraction of muscle that's water is like 2/3. But yeah, so if you do the arithmetic, and instead of doing it by volume fraction, if you were to line up all the molecules inside the muscle and count them one by one, more than 99 out of 100 would be water molecules, because the water molecule is so small. So to take up that 2/3 volume, you need a whole lot of them. And so I began to think that, this is really weird that nobody is taking into account the water inside the muscle. Almost never is the word water discussed. And if you look in the textbook, you'll see all the proteins there, but there are no water molecules. So it's like these proteins are operating in a vacuum, and nobody talks about it. So I was thinking, this is actually really, really important to study. And there had been one colleague in my lab many years before that, an Israeli guy who was talking about water. And at the time, I thought, well, he's way off. Everybody knows that it's not water. But I began to think that water must be important in some way, because it's preposterous to think that something where 99 out of 100, more than 99 out of 100 molecules are of one kind, and that kind of stuff is irrelevant. So it didn't make sense. At the same time, I had the really good fortune to meet someone who made a really important impact on my career. His name was Gilbert Ling. And Gilbert came from China. and his interest was water. And I got to go to a meeting where he was there. It was a meeting to commemorate the death of a famous Hungarian biophysicist. And his interest, the biophysicist's interest, was muscles and water, two different fields. And I was to represent muscles, and Gilbert Ling was to represent water. So we crossed paths, and it wasn't long before I came to realize that Gilbert Ling's radical ideas had some merit. And so what are his radical ideas? He's had many. He's now 100 years old, by the way, still kicking. Yeah, wow, is right. Wow. And he was selected. He was in the first group of scientists to come from China. After World War II, there was some attempt, I don't know who drove the attempt, to get Chinese scholars to come to the US. So they searched all around China, and they picked 3 people. So he was one of the 3 from all of China. There was a biologist and a chemist and a physicist. And he was, I guess, the biologist. So he came. The physicist, by the way, won a Nobel Prize in physics. So this was a very select group of people. And I was so impressed with what Gilbert had to say. And he was saying a very simple thing. He said, inside the cell, the water is not like this, not like a glass of water, where the molecules are bouncing around randomly, a huge number of times each second. The molecules are ordered. In other words, the molecules are lined up like dominoes, one after the other, inside the cell. Mm. This idea was completely at odds with the prevailing view of cell biologists who assume that water is like the water in the glass. It's no different. Mm. This presents a sort of problem when you think about it, because I was just discussing, because we were just today before this at doctors, my wife has some health issues, and we're discussing the fact that, if your cells are filled with water is a liquid. If you cut yourself, all that liquid should pour out of your body, but it doesn't. So this is a sign that there's something different about the water. And the water that Gilbert was talking about is somewhere, you might say, between a solid and a liquid. Well, that's how, a long answer to your short question, that's how we got started. We were studying muscles. We came to realize that water is probably important. We met Gilbert Ling, who said that water is critically important, and also it's different. It's different from ordinary water. So it didn't take very long before our lab pivoted from focusing rather intently on muscle contraction to focusing rather intently on water. Yes. That's how it all began. Sorry, long answer to a short question.
Oh, no, I love the long answers because it paints the picture fully. It paints a picture in color rather than just in black and white outlines. So it's great. Now, in formal training, we're taught about the 3 phases of water: solid, liquid, gas. And there's a 4th stage.
Yes.
Could we touch on that now?
Absolutely, yeah.
And explain what this stage is.
We starting with Gilbert Ling's ideas. He was an important stimulus for us, a great stimulus for us. We knew we wanted to do experiments on water because this seemed so interesting. We had to learn something about it, and the idea of a 4th phase came a bit later. And we knew that the kind of water that Gilbert Ling was talking about, where the molecules are lined up, it's kind of like ice in some way, where the molecules are ordered, lined up. And when you freeze water to get ice, what happens is, as the ice crystal forms, or as the crystals form, they push out, they exclude any kind of foreign substances, either substances, solutes, or particles and such. So we were looking, our clue was, we want to find some kind of setup or model or something where we could see this kind of exclusion happening. It wouldn't prove necessarily that this was a region of structured or ordered water, but it might give us a clue, and we could find out later whether it really was or wasn't. And I had the good fortune to meet a Japanese colleague who told me about an experiment he was doing. And I thought, this is it. This is really important, because he was talking about a gel where there was a tunnel in the gel, and he was using this tunnel to study blood flow. But blood is messy. He didn't want to deal with blood, so he dealt with water and little particles to represent the red blood cells. And he was telling me that when he did this, his students noticed, because they could see inside the gel, it was a clear gel, they could see that just inside the tunnel, that there was a region where these particles, these so-called microspheres, didn't want to go. In other words, a clear zone. So you have the tunnel, and right in the middle of the tunnel, you have all the particles, and they're excluded from a region just inside the tunnel. And he was thinking, oh, it must be some kind of secondary effect or something like that. And I was thinking, this is the clue I was looking for, because I think this is a region where the water is structured. And because it's structured, it's pushing out or excluding all of those particles. So we became friends. I wrote an email to him. I said, please, could you publish your paper on this? Because I would like to quote it in my book. And this was the book that came out in 2001. It's called Cells, Gels, and the Engines of Life. It was my first book on water. We hadn't yet come to the fourth phase. But the book demonstrated how central water was to all of biology. Anyway, he wrote back and he said, yeah, we're working on it. And then a couple of months later, please publish your book. I really want to quote it, or publish your paper. I want to quote it in my book, because this is important evidence for structured water, I think. And finally, I was a pest. I was really eager to see this happen, but he wasn't doing it. And finally, he wrote to me and said, look, if you just leave me, he didn't say it exactly this way. He said, if you just leave me alone, I'll make you a co-author in the paper. I don't want to be a co-author. All I want is for you to publish the paper, because the contents are so important, and I want to use this in my book. Well, what happened after that is I had the good fortune, because somebody from his laboratory came to my laboratory just by coincidence.
Yes.
I was able to start repeating these kinds of experiments. And so that was our beginning. We thought that this region of exclusion corresponded to the region of ordered water. And it didn't take us long to confirm that that was absolutely true. So we got started that way. And we went on, and so it took several years of doing. We were relatively new at these kinds of experiments, because we had plenty of experience studying muscles and their contraction, but no experience at all studying these kinds of preparation. So we learned on the job, you might say, and I think we learned reasonably well. We found out so much information about these zones. We call them exclusion zones, because they exclude water. And we found out the structure of these zones. And we think that Gilbert was not quite right in his idea of the lining up of water molecules, like lining up of dominoes. The evidence didn't fit that. The evidence actually fit more like a structure a little bit like ice. It has a hexagonal motif, and it consists of hexagonal sheets that pile up on one another to give you something that grows in thickness. And we found that this kind of water with the structure that I mentioned to you, we called it fourth phase. Well, first of all, because it's simple. Second, it tends to be alluring for people. A fourth phase, that's interesting. But it really is a kind of water that differs. It's not a liquid, and it's not a solid. It's somewhere in between, and it's certainly not a gas or vapor. So we call it the fourth phase, and this fourth phase, because its structure is not so different from ice, we found out that in fact it's an intermediate between water and ice. So if you take a glass of water or a container of water and you freeze it, we found that you can't go, as people think, directly from water to ice. You must go through this easy phase. We have experimental evidence that's published, and it's described also in my later book, which is called The Fourth Phase of Water. It's been very popular. Sometimes when I'm in depressed mood or something, I look at the reviews of the book on Amazon. I'm kind of thinking, I wish my mother were alive, because she'd probably print it and post it on the wall of her apartment.
Yes, yes.
Yeah, so it's a popular book. It's written for people who are non-experts in this, and it describes what the fourth phase is all about. So I told you about the history, but I haven't told you about the importance of this water. But I'm ready to answer your next question, and we can get to it later or whenever.
Okay, well, how stable is the stage of water? You've explained how it can be on the edge of a gel tube, and it's also
On the edge of what?
of a tube that's got flowing water going through a gel tube.
A tube. Okay. Yeah.
And you've explained how it's an intermediary stage between liquid and solid when it's freezing. How stable is it? Can you have a fourth
Well,
in
yeah,
a bottle?
it's a good question, and we don't know the answer exactly. So usually we found that building up this kind of water, if you start with plain water, and you have just a little bit of this easy water, if you add light to it, it builds. So the energy for construction, anytime you want to go from a state where something is disordered to a state where it's ordered, you need to put in energy. One example of that, my favorite example, is cleaning up your room. So you look like a guy who's pretty neat, but most of us are pretty sloppy. It's like falling off a log to be sloppy. You just put something down here and something down there, and it requires no real energy to do it. But if you want to make it neat and clean, you have to invest energy. So you spend a half hour moving this from here to here and so on. So that's a good illustration of the principle that you need energy to create order. And so we found, to our surprise, through a quirk of a student experiment, we found the energy that's needed to build this water comes from light, and particularly from infrared light. So, light, the visible spectrum starts at the short wavelength and the violets and gets longer and longer through the reds. But beyond the reds, you have infrared, and beyond the violets, you have ultraviolet. So it turns out that the infrared wavelengths are by far the most powerful for building this. And so where do you get infrared energy? Well, most people know if you're in the kitchen and you look in the electric oven, you see the coils glowing bright orange, and you feel the heat, and so you say, oh yeah, well, infrared is associated with heat, and that's not wrong. But actually, infrared is all over. So you can see the images behind me, the musical instruments and the artwork. There's an artistic streak that runs through me. And if I were to turn off all the lights and you couldn't see any of that with your eyes, no visible light that detectable, you take out your smartphone and you get no image. But if you have a camera with an infrared sensor, so it senses those long wavelengths, you get a beautiful image of everything, even if it's perfectly dark in the room. It's because everything is generating infrared energy. I am, the musical instruments there are, the picture, the walls, everything. So it's basically free. It's free for the taking. You might want to call it, if you were not a chemist and familiar with the term free energy, you might call it free energy because it's free. It doesn't cost anything. And that's the energy that builds the water. So it's a long answer to your short question about stability. But you see, since this energy is always there, and this is the energy that's required to build this water, it might be that this is actually pretty stable. We tried some experiments, and the experiments were not conclusive. It's a really good question about the longevity of this kind of water. So a guy who produces water for health, there are many such people, he was telling me on the phone when he called me about this extraordinary water that he produces that can actually reverse irreversible kidney pathology. At first, I said I didn't believe him, so he sent me hospital records, and it confirmed that irreversible kidney pathology disappeared after a month of drinking this water. So I became more impressed, and I said, why don't you send me a sample of this? Maybe we'll test it. And we tested it, but it took 3 months by the time it arrived in the mail until the time we actually got around to testing it. And we have a very simple way to determine if there's easy water. It contained a lot of easy water. So we can't, with an experiment like that, n equals 1, we can't really tell about the stability because we don't know how much easy water there was at the outset, but at least a very major amount of easy water persisted or was there after 3 months. Maybe the infrared energy in my office is enough to keep it that way. So we don't really know the answer. It is possible that that this is a very stable structure, but we're not sure yet. Oh, sorry.
Oh no, never apologize for a full answer. It's wonderful to
No, I apologize because it would be nice if I had the answer, but
I understand. No,
academic, we tend to hedge if we don't know for sure.
Now, a lot of people are jumping on the bandwagon of health and healthy supplements, and of course, healthy water with this and this. I've had a question from Steve Jeffion, who's wondering, now I won't put in brand names to the question, but there's a water distiller that supposedly changes the hydrogen bond angle in ordinary water from 104 degrees to 114 degrees, and therefore produces over 100,000 life-saving results. Now, is there science in that, or is it really just?
Yeah, I mean, I'm not familiar with that particular water, but I can tell you my opinion. So you can't see a water molecule, and so it's not so easy to measure the bond angle of something that you can't see. The bond angle is inferred from various measurements, and typically these kinds of inferences involve a whole long list of assumptions. Okay. I wouldn't bet my life on the bond angle and what the bond angle is and how it changes. But I think more important than that, a lot of people studying the various waters, each one says something different. Oh, our water does this and it changes this, and some of those may actually be true. I'm not sure they're true, but I think the proof is in the pudding, and I think the real proof about the value of a particular water has got to come from clinical trials, from you've got a group of people who have kidney problem, okay, and they all have the same sort of kidney problem, and 20% of the people drink water A and 20% drink water B, and et cetera, and a control group, maybe they drink tap water, and there are local taps, and test them, check them at the end of the year and see what happens. Right. And I think that's a not unreasonable way to check it. But who's going to do it? See, the problem is that the water companies, they're not wealthy. They don't have the same kinds of money that drug companies have, where they can spend $100 million on a drug trial to see if it really does help with cancer or doesn't help with cancer. They don't have that kind of money, and so it's not so easy for them to test. But really, that's what needs to be done. At one time, I was really eager to do that, and I had hoped that our National Institutes of Health might come forth. It's not cheap to do something like that, as you can imagine, to do it correctly. And I thought that with maybe $5 million, we could conduct enough trials to be meaningful, so that if you ask me, my brother-in-law has cancer, which water should he drink to see if the cancer will disappear? And so it strikes me as something incredibly important for an organization that spends, I think NIH now spends, close to $40 billion each year on health, and that includes drug testing and such, but no interest whatsoever in water. Water? That's just the stuff. It's like the stuff that bathes the important molecules in life. It doesn't do anything. So why are we going to waste $5 million on something like that? So this is what I think needs to be done. Maybe somebody in China or or something will come forth with some money, or I'm not sure, and I'm not sure that we're necessarily the best to do it, but I know who shouldn't do it, and that is one of the water companies, because obviously they have some self-interest in the product, but it should be done. So I can't really tell you anything meaningful about the bond angle change.
I guess the question that could be asked is, how did they measure it? And can they give?
I'm not sure, frankly. I haven't followed.
No,
It's really difficult because there are literally, I'm sure, more than 100 companies who've come out with some people that are interested in water, water for health. And there are all kinds of processes that are used to produce waters. In Japan, for example, very popular is alkaline water. Perhaps you know about that?
Yes.
Yeah. And a colleague who studied that water told me that the Japanese government did tests on that water. They did actually the clinical tests. And the fellow told me that the results of the tests were so incredibly positive that in Japan right now, if you go to your physician with any kind of gastrointestinal problem, starting from your mouth all the way down to your rear end, anything, they tell you to drink this alkaline water and they pay for it. So it's not just lip service. They're actually coming through with money to pay for it because they've tested it and the tests have come through really, really positive. There are other reports here and there that this water is not so good for you. So I'm not in a position. We do fundamental research on the chemistry and physics of water. We're not water testers, you see. But it would be great if knowledgeable people who are independent of any of these companies and such could actually test various waters. Incredibly important for the health of the world.
Absolutely.
So maybe you can inspire some of them.
Well, I'm sure, I'm hoping that some of our viewers, I only need one viewer, so yeah, I can do it, and I've got the ability to do this, to carry that through and do the research on water and make things happen. An online question from Paul Schmittendorf. He's asking about frequency infused water. Have you had any experience in imprinting water with frequencies?
Not specifically in our laboratory, but I've heard enough about it from people whose opinions I trust to know that there's something to it. And the original, as far as I understand, came from Royal Rife, who used various combinations of frequencies to treat different pathologies. And I think he lost his license because they thought he was a charlatan.
Sure.
And someone finally discovered some of his notebooks, and some of the information in the notebooks is available, and various people are producing so-called Rife machines that produce frequencies. There's also so-called frequency-specific microcurrent group, and this is a group who have revived some of the work from yet another physician who used different frequencies. They came across the information that was recorded, and they're starting to use it. And I went to a conference just a few months ago and the conference was about frequency-specific microcurrents.
Yes.
And I heard reports from various physicians, including quite a few from the Cleveland Clinic. So this is, a reputable place. And they're reporting extremely positive results. Excuse me. Positive results from using those frequencies on people. So they put two electrodes, for example. They might put a wet towel around here and another one at a different,
yes.
and pass very minute currents, different frequencies. Usually it's a combination of two frequencies, and the results that they report seem just remarkable. So my answer to it is we have no experience ourselves. However, I've seen enough to think that this is really interesting and probably valid. It needs more development, more clinical trials and such. But this is a extremely inexpensive method of curing ills that could cost huge amounts of money in more conventional kinds of approaches.
Yes.
Yeah. So, yeah, there are many things out there, but a lot of them don't see the light of day. And
Okay.
I think we all understand some of the reasons why they don't see the light of day. It's sort of
Absolutely.
follow the money.
Follow the money. You mentioned before about far infrared and how it is a wavelength which is very conducive to the creation of the fourth stage of water. Thomas Gersten asked the question, far infrared saunas, do they, well, I'll restructure, well, I'll totally ruin this question completely. Do far infrared saunas structure water inside your body in any way?
Well, I never went inside the body to check to see. However, it would seem a no-brainer because you go. The answer is yes, a no-brainer. I would think because you go into a sauna, it's hot. The amount of infrared energy is huge inside, and it's exposed to your body. You don't have any clothes on to block it, but even if you did, it wouldn't block all of it or much of it. And your body's absorbing for 15 to 30 minutes this huge amount of infrared energy. And if the workings of your body are similar to the workings of what we explored in the laboratory, then you get a huge amount of growth of easy water. And then, so you might say, well, what's the big deal? So what if easy water grows? Well, the so what is from the earlier book that I mentioned, The Fourth Phase of Water. This structured water, as Gilbert Ling likes to call it, and some others, ordered water, is absolutely central for everything your body does. I was mentioning muscles, where it's absolutely essential as a trigger, but pretty much every organ in your body needs that water because every protein, here's a protein, and the protein is surrounded normally by this kind of easy water. But if you're ill or dehydrated, the two are not synonymous exactly, but they're pretty close. If you're dehydrated, this stuff is missing or in short supply. And the protein doesn't, oh, hey, I'm in a weird environment here. What do I do? And the job of the protein is to fold like this to cause contraction, or if it's a secretory cell, to fold like this or that to cause secretion, or if it's a nerve cell, to do pretty much the same thing to pass on information. It's all essentially the same, thematically the same process. But if the water's missing, the protein finds itself in a strange environment, in a kind of wilderness that it doesn't recognize. Instead of doing this, and it will kind of misfold, and it's not working, and you have a pathology. So you want to reverse that. So, I mean, for example, if you have a muscle ache or headache or something, you go into the sauna, you absorb all of this infrared energy. It should rebuild the EZ water that's been missing. And then, so you go in with muscle aches and you come out feeling okay. You go in tired, in my experience, come out feeling like I just woke up. I had 8 hours sleep. I feel great because your cells and all the organs of your body, they're all getting restored to where they should be. So the answer is to the person who asked the question is an absolute yes.
Oh, okay. Does hydrogen water have any association with the fourth stage?
I don't know. We haven't tested. I know that that kind of water is getting popular. I'm not aware of the clinical tests on it, but the reports have been good. But I'm not sure of details. Sorry about that.
Oh, no problem. An anonymous attendee has asked, is there a particular part of the infrared spectrum that can create easy water?
Well, yeah. So the answer is partially yes and partly I'm not sure. So we studied, in the laboratory, we like to study as much as possible. We can, but to get the infrared sources, we used light emitting diodes, LEDs, at the various spans of wavelength. We could get them up to the wavelength of about 4.5 micrometers, which is, depending which book you read or how you define, is kind of middle infrared, middle to far infrared. So we could test in the range through from the UV, through the visible, through infrared, up to wavelengths as long as 4.5 micrometers. And we found that 3 micrometers was the most effective. Also, 1 micrometer was pretty good, but not nearly as good as 3. What we also know is that 3 micrometers is the wavelength that water absorbs the most. So we could conclude, other evidence too, we could conclude that the wavelength that the water prefers to absorb is the same wavelength that builds EZ, or in other words, this absorbed energy goes into building EZ. But we know that the longer wavelengths beyond 4 or 4.5 micrometers, water likes to absorb it. Not quite as much as 3 micrometers, but not so much less. So it is possible that these much longer wavelengths also build EZ water. We don't know that for sure, but this is an experiment that needs to be done.
Okay, well, we'll start on another question from Tav Keen. He asks, can you create easy water with an array of magnets? Does it take any magnetic field to?
Maybe. This is a question that is right on our agenda at the moment. So some funny things happen when you put a magnet next to water. The first thing that was found by a guy from Eastern Europe, from Belarus, who joined my laboratory. And the day he joined my laboratory, he showed me a paper that he had just published. And it was interesting for me because my student had done exactly the same experiment and got exactly the same result. And that is, you take a glass of water and you put a magnet underneath.
Yes.
And if the North Pole is on top,
yes,
and you wait for a day or so, the pH of this water changes. I think for the North Pole, it increases. And then if you do the opposite experiment, you put the South Pole here, the pH decreases, like mirror images of one another. And we both got the same result. I had no idea he was doing that experiment, and of course he had no idea that we were doing. Ours is not published yet, but his is published. So something interesting happens to the water, and we're not sure yet what. He also measured the absorption properties of water at wavelengths, short wavelengths corresponding to the ultraviolet. It turns out it changes. You put a magnet there and the water absorbs more or less, I can't remember, the curve shifts. And that persists for months. So when you put magnets next to the water, we're confident, and other people have demonstrated too, something changes in the water. Whether it creates EZ or not, I guess I'd wager probably it does, but we haven't identified it. Because we know, for example, that if you have EZ that's being created in the water or anywhere, the EZ is usually negatively charged, and the water around it receives positive charge that complements that negative charge. So in other words, part of the charge that was the water starts neutral, and you break up the water molecule, and the negatively charged parts come together to form this EZ, and the positive ones get pushed into the water. They're free. They're bouncing around. And it's possible that that's what's going on. But in order to demonstrate it, we would need to demonstrate the presence of EZ. We're working on it, so we don't know the answer yet. But magnets definitely have an effect on water. And it could be health promoting. We don't know. So I know people tend to use magnets in certain ways to improve their health. And it might be that is the underlying basis. Not sure.
Right. So they could explain why people say put the North Pole of a magnet to your body, and the water inside your body is reacting to the North Pole and possibly becoming this easy water as you...
It's possible. Again, I wouldn't want to bank on it, but I would think that's fairly likely. I hope we know within a year.
What is the significance of the difference? We've explained what the fourth phase water is, but why is it so important in your body? Why is it?
Because, well, there are two things. First is what I was trying to explain before about the protein folding and the natural environment or milieu surrounding each protein. Yes. The cell is full of EZ water, and that, by the way, I think is what confers the well-known negative charge inside the cell. That's been confirmed for 60 years, and people think it has to do with the membrane,
Yes.
and I don't, and I have a paper that we wrote about that as a simpler explanation rather than the pumps and channels in the membrane, and that is the water has negative charge, so the cell is negatively charged.
Yes.
So the question was, why tell me once again, I'm sorry.
Oh, well, what is the significance of the easy water in your body as opposed to glass water?
Okay, so that's one. And the second way of looking at it is as an energy supply. This water is negatively charged. So if you think of a cell, the cell is full of these negative charges. These negative charges repel one another. They want to get out as quickly as possible. They can't get out because they're stuck around, but there are ways that they can get out, and this is potential energy. It's sort of like the terminal of a battery. You know, one terminal has positive charge, the other has negative charge, and there may be positive charges outside the cell, but inside it's mostly negative charges. So this is like a battery, and this battery essentially delivers energy because as the cell goes from its quiescent state to its active state, in other words, if the muscle is relaxed versus contracting, or the nerve cell is not doing anything versus transmitting information, then if that's the case, then it's delivering delivering that energy in order to do so. So most of us think about that the energy delivery inside the cell has to do with ATP, the high energy bond in the phosphate delivering the energy. There are some people who think that that's actually not correct. I'm not sure either way, but there have been challenges to that really early on. And Gilbert Ling, sorry, somebody's knocking at our door, but we'll let it.
They want to join SEMA, don't they?
Well, I don't know who. And my wife, being deaf, doesn't hear it. And we have a guest at home, but he's downstairs, so I guess the door won't be answered. Someone is really anxious, probably someone who is wants us to vote for a particular political candidate. We have some issues in this country, as you know. But anyway, this is we're talking about separation of charge. This is a little bit like photosynthesis, where light comes to the green plant, separates charge, and that separation of charge is the first step in a long chain of steps in photosynthesis, which gives energy to the plant. This is very similar, except it works in your cells and my cells, not just the cells of the green plants. And therefore, it's completely analogous, the two of them. And this is, I think, an important energy source for your body. So if you want to think way out of the box, you maybe know about these people called breatharians who don't eat, and they do. And I know some of these people, and they're absolutely sincere. Many people say it's impossible. I mean, but these people seem to do it. So the question is, well, where do they get their energy? And I think it's possible. They think so too, that the energy comes from light, that they absorb light from the environment, and the light does almost the same thing that it does in plants. It separates charge, and that battery-like effect is used in your body. I think this is true. We may get a lot of energy that people don't think about in much the same way as plants get their energy.
Right. Can you have too much easy water in your body?
It's a good question. I don't know the answer. It's probably self-limiting. One of the reasons I think about that is if you have a biological structure, let's say proteins that look like this, and usually they're cross-connected with cross-links like a comb in between them, and that prevents them from separating by too much. Now, when the water builds next to the surfaces of these proteins, they'll build one layer, a next layer, a next layer, and there's a tendency, if they build from this surface and this surface, a tendency for these to separate, right? Okay. But the cross-links prevent that separation, so it's self-limiting, and you can't build a whole lot of easy water. On the other hand, if you have an accident and you strain some muscle or joint or connective tissue, whatever, these links break. And once they break, the water can pile up very quickly. These separate, and you get a huge swelling.
Yes.
And I think that's how swelling occurs so quickly.
Right.
So that would be a pathological state. And the state that's not pathological would be the normal state, where the cross-links are present and they prevent this overextension and thereby prevent too much easy water from building up. So your question might be moot because the amount of easy water that builds up could be limited.
Okay, I understand.
Not sure, but it's a speculation.
I got asked to propose this question to you. It's a very important one. The countries throughout the world are rolling out 5G. Now, we are filled with water. The water absorbs frequencies. You can imprint frequencies into water. And you've got, of course, this fourth stage phase water in your body. What is, in your opinion, the effect of these very powerful microwave frequencies passing through your body?
My opinion is irrelevant. What are the facts is really what you mean. And so I haven't studied it myself, but I've heard from enough people whose opinions I respect who have studied it,
Yes.
who tell me that this is disastrous. This is potentially lethal. You know, right now, the Wi-Fi that we have, I guess you'd call it 4G or whatever, 3G, is itself, you might say controversial, but my colleague in my department who just retired, who studied these sorts of things, he reminds me that there are a lot of studies undertaken about the effects of this kind of radiant energy that comes from Wi-Fi on human health. And he said, the ones that are sponsored by the cell phone companies, they report 95% of the papers say no effect. On the other hand, the ones that are sponsored by foundations and so 95% report serious effects.
Gosh.
So you have to weigh the differences between who is funding. If I'm getting funded from a drug company, for example, and I want to get more funds in the future, if there's any question about interpreting the data, I might be persuaded to interpret it, giving some favor to the person who sponsored it because I want to get more money to support my work in the future. This is an issue, and the issue is a serious one in trying to answer your question because of the difference in the results depending on who's funding the study. But what I've heard about 5G is because it doesn't travel very far, so you need boosters such about every block or so. So it means there are going to be little boxes on telephone poles and such every block, and the intensity is very high because it doesn't propagate very far. And so the reports, secondhand, I haven't seen them myself, but as I said, these are very serious people who have studied these reports, and almost uniformly, the ones who have studied it said, this is potential disaster for the human race. So that's all I can say because I don't have firsthand evidence. We are actually starting in the laboratory to study the effects of Wi-Fi on EZ water, and it's too early to say. So I won't say.
Okay.
So we should have results pretty soon.
So to find the validity of results of studies, you just follow the money again.
Well, we're not supported in this by any particular agency.
No. So you'll be more neutral.
Our support mostly comes from very generous people who believe in what we're doing and are supporting our laboratory. We're very thankful for these people because getting money from, if you do anything that challenges the conventional point of view, it's almost impossible to get money from various agencies because the people who are reviewing your application for money are the ones who are being challenged. If someone comes to me, if I had money and said, I give me some money for challenging your theory, I might actually be not so generous as I would for somebody else who comes to me. I love the work you're doing. I want to enhance it and get some more. Oh yeah, sure. So you understand the situation. So it's a true blessing to be able to have funding from sources of people who believe in what you do. It's the old-fashioned way.
What advice would you give to young scientists, researchers, starting off?
Oh, I wish you hadn't asked that question. Let me put it in a diplomatic way. If you want to do real science, which is mean discovering something, usually if you discover something, it displaces the people who held the prevailing view. Right? I mean, you discover something new, and it pushes out the previous view. Otherwise, it's not new in any way. So if you, for example, if you said that gravitation, you're proposing that gravitation is caused by, say, electromagnetic energy instead of mass, for example, and you put in the proposal, and even better one. So the world thinks that the Earth is flat, okay, and you come up with a proposal that the Earth is round.
A crazy proposal.
Crazy proposal, and you say, well, I've got some preliminary evidence. I've seen photographs from satellites, and it kind of looks round, and I took a flight from Seattle, where I live, and I went to Tokyo, and then Shanghai, and Ulaanbaatar, and London, and New York, and back to Seattle. And I was looking out the window, and I couldn't find the edge of the Earth. So something is wrong with that idea, and it seems that the Earth is not flat, it's round. Please give me some money. And so the fate of that application. All of the flat Earth people are going to say, this is nonsense, we're not going to fund it. So your question was a bit different. What about a young person? What advice? And if a young person is seriously interested in discovery, finding new things, it's not easy. It's a real obstacle. It's different from how it was, say, 50 years ago. And because of the situation with funding, because the people who are selected to review the applications, those people are mainstream people who they're chosen because they've achieved a lot successfully. They're the ones who are going to be reviewing. So what I'm getting to in this roundabout way is it's a challenge for any young person who wants to go into science because it's hard to get money, and without money you can't do anything. And so a lot of young scientists become conservative, and they follow, they study within the narrow confines that are considered okay to study. So it's an obstacle. We are trying to solve this problem. We have an institute called the Institute for Venture Science, and it just started. And what we do is to fund promising ideas that challenge tired, outdated conventional views. And if anybody is interested, please contact me. We're looking for donors. We already have 5 extremely exciting projects in mind. And for young people, I'm really hopeful that institutions like ours, Institute for Venture Science, ivscience.org, are going to have funds available to them to do projects that lie outside the mainstream, because this is the future. Not supporting old paradigms that don't work, but looking for new ones. There are lots of people out there who want to do it. Young people are among those. That's the obstacle. So my advice is be prepared, because it's an uphill battle, but it can't be more rewarding than being able to discover something that's fundamental in nature. Right. I can't think of anything more rewarding than that.
Yes.
So this is my advice.
That's great. Well, thank you very much for your time. Would you like to close on a very positive note? If you can think of something that you can think of very positive with regards to easy water.
Well, yeah, we're working on it. We formed a company, and we're trying to translate some of the laboratory discoveries into practical devices that can solve some of the world's problems. And we think this will help. We're working on it. We need additional investment, but we're working on getting energy from light and water. We're working on filtration using this easy principle where you don't need energy to do the filtration, and you don't need filters to clean and wash. And the separation is by virtue of the infrared energy that I was talking about. It separates easy water, which is free of all the junk, all the pharmaceuticals, all the bacteria and such. And we're working on that, translating the laboratory experiments into technology.
Yes.
Is really demanding. To make useful technology is not so simple. It's demanding, and it demands of investment. And so we're trying to get there, and we're hopeful we'll do something really positive for the world.
Wow.
Thank you so much for your good question.
If you can also, sorry.
Yeah.
Oh, if you can give your website, please, so viewers know where they can find more information.
Just look under Pollack Laboratory, Pollack Laboratory, University of Washington. And I don't remember the URL, it's too long. But
Okay.
if you look on Google or whatever, you'll find it there. Okay. There are a lot of Pollack Laboratories, but University of Washington, you'll find it. For water, keyword. Thank you.
When you publish our video, we will put the link on the bottom so people.
Oh, that's great. Thank you so much.
Well, thank you so much for your time. I understand it's very late in your side of town now, so I'll let you go. Fantastic talking to you. You've given fantastic information, and it's a paradigm change you're talking about. People think there's only 3 stages of water. Water is something so simple. The English phrase, you water something down. Well, that means make something less important, doesn't it? But actually, water plays a more than a greater than significant role in the healthier body. And
I think it's absolutely true. And it used to be true that people studied the chemistry of water, but there were a few incidents that took place that were very embarrassing for various people, and scientists, thinking about the potential for that kind of embarrassment, stayed away from studying water. So water science basically disappeared for a couple of generations. It's now back, and I agree with you. It's extremely important. Water is so central to everything in nature, and I mean, it's incredible to think that there was such a hiatus of 40 or 50 years where almost nothing was being studied. It's coming back. We have a conference each year for any of your viewers. It's a conference on water, and this year it's going to be near Frankfurt, Germany in October. And if you're interested, it's WaterConf, C-O-N-F, Water, C-O-N-F, as for conference, conf.org. And each year it's better and better. This is the 14th year. So many interesting presentations, novel presentations that you won't hear anywhere else, and such a nice informal atmosphere where people can get to know one another, rub shoulders with people you've heard about and you'd like to meet, et cetera, et cetera. Highly recommended.
Fantastic. Okay, have a fantastic evening.
Good night. And you too. Thank you so much.
Thank you.
Bye-bye. Okay.
And
I guess we're done.
We're done in all meeting, we're absolutely done. That's right. Well, okay. I really enjoyed the time we spent together. It was great.
Yeah, thank you. And I apologize. It was almost late. And I just heard from Nick. I don't know who Nick is, but I guess he's your technical guy or something.
He's the guy that does all the hard work and organizes things.
Yeah, so, but he advised me 5 minutes ahead of time that he would like to get us started at 20 minutes before the hour. And I had taken my wife to a medical appointment.
Yeah.
And we got finished so late in the traffic, and so I emailed him. I hope it's okay if I'm 10 or 15 minutes late. I didn't know if it was live or not live.
Gerald, it went perfectly. Don't worry about a thing. It went perfectly.
Well, too late anyway for whatever.
Please put your attention to your wife now. Make sure she's okay.
Thank you so much. Appreciate you. Where are you located?
I'm located in China. I actually live in China. You could probably tell by my accent.
I was thinking Australia or New Zealand, but
New Zealand, yeah.
Pardon me? What?
New Zealand. I was born in New Zealand.
Such best place on earth.
Oh, thank you.
Why would you want to move from New Zealand?
Well, China's got so much potential. New Zealand's a small country, and you can only grow a certain size.
Yeah.
Not in a business sense, but in a personal sense.
Yeah.
We still go and visit New Zealand regularly, well, once a year.
Yeah.
And I've got all my friends, a lot of family of friends and family there. But China's. I just needed a change. You get time in life, you just want to change, just want to spread your wings.
I hear you. Yeah, and I know that New Zealand can be a pretty conservative place with limited opportunity.
Yeah.
But lots of sheep.
And we have pink sheep as well.
Sorry, you have what?
We have pink sheep as well. Just north of Warkworth, if anyone wants to see pink sheep, just north of Warkworth, you'll see pink sheep grazing out there.
Oh, pink sheep.
Pink, bright pink.
Okay.
Pink in colour, yeah.
Oh, wow. No, I haven't seen that. Okay, that's great. We had a great time in New Zealand. Okay, anyway, I got to go. Thank you.
Okay. You take care. Bye-bye.
Okay, bye-bye.
Bye.